Hello, hello,
Noel,
hello.
very early good morning to you, Zach.
Well, it's late in the evening, so good evening from me.
Amazing. Another session with the multiple time zones. That's nice.
Yes, and all over the world. So we
Yes.
have you from New Zealand, we have a guest from the East Coast, and I am in the middle. Awesome. So, how's
Cool.
it going, Zach?
Good, good. Being busy with the Sydney Summit is coming up, so I'll
Mm-hmm.
be doing a
Mm-hmm.
talk.
Mm-hmm.
And our community day things are going on, and being busy with those things. So it's next to next, back to back. Every day there's a call and meeting. It's not easy to organize something, right? Because we want to
Yep.
deliver
Yep.
amazing community work. So yeah, it's been amazing, and yeah. And since I got my driver's license, I'm driving around always now.
Mm-hmm. Mm-hmm. Sweet, sweet, sweet. Yeah, it's the season of summits, community days. So yeah,
Yeah.
we just wrapped up Bangalore Community Day. Sorry, Bangalore Summit.
Summit, yeah.
Community Day. We have it next week, and also there is summit happening in Mumbai later in June. So yes,
Yeah,
busy
and I would
time.
like to give kudos to your Bangalore team, like amazingly helping us
Mhm.
with our community, with all the assets and all the design. So that's amazing because this is where real community works, right? Like collaboration, and we don't expect anything, right? Like we just helping and different time zones. That's amazing. Like especially Avinash, and he's willing to uh, book a call like different time zones, and yeah, that's amazing. Kudos for the Bangalore team.
Yeah, it's community and collective efforts. So yes, kudos to
Yes,
the New Zealand team as well.
thank you.
Awesome. Do you want to introduce who our guest speaker is?
Yes. So I think everyone knows already seen the banner, but I introduce as like a surprise. He's actually a really good friend. Like I think I know him since a long time ago. Like not even before. I mean, even before he became a hero. Like I was following him, his amazing contents, and recently he's publishing a lot of Instagram reels, and it so motivates me. You know, day to day I check those things, and it so motivates me. And I never miss his reels or stories. And one more thing I've really impressed, like he balance everything. You know, like his health side. He's like, yeah, going to the gym every day. It kind of motivates me. So now I'm doing the same. So
Mhm.
drum roll. Let's welcome Brian.
Hello, Brian.
Oh, how do I leave from that? Like warm and dry. I feel like in like the Super Bowl or like
Yeah,
big soccer game, and then
yeah,
it's like you're like all like the horns going and everything. That's awesome. Thank you so much for the intro, Zach, and also Zach. Thanks for having me on the pod.
yeah.
Yeah, thanks for taking
Thank you.
time in the middle of your day. And
Oh
yeah,
no, of course, of course. Anything to like get get a little bit of a break in and around like I am like provisioning issues or like deployments and stuff. So no, always happy to jump in. I love your show. Like I love following like other content creators that are also techies. So it's
Mhm.
really fun to just like build a community. I love like the whole brand and like especially the intro. Like whoever did the intro, like that was sick. Like the graphic animation stuff. Like I just think like this is literally how I learned how to code was people making content like this and then educating, and then you're like kind of like Zach when you said like, oh, you see content, it inspires you. You like see a podcast and be like, oh, I want to like be like Zach one day and like be building that type of tech. So this type of content matters a lot. So I love what you all do. It's so cool and important.
100%. It's not
I
about
mean,
talking about the tech stuff, right? Like how to do this, how to do that. It's like how you, yeah, deliver to the community, right? Like
Exactly.
we love the community and we are giving back to the community.
Yeah,
absolutely. Yeah,
totally.
you've been doing some amazing stuff as well. With all the reels that. Okay, I'm not an Instagram active person, but yeah, I do see the reels on LinkedIn nowadays. Yeah.
That'll be my goal to get you more on Instagram. It's like it's actually funny because when I was a community builder, I connected with several people. Like I'm sure like we all know Linda from AWS, but like I knew her like before she joined AWS through Instagram. and there were like a
Wow.
lot of people that I connected with on Instagram. Like it's cool to connect with people, like even like Aaron Hunter from like AWS. Like we were like talking on Instagram, and then like we meet at like New York Summit, and it's like, oh, like you're that person from social media. So and Steven, like being able to connect, hey Steven, like being able to connect with like real people. Like when I was in Seattle last year, actually I met up with Steven like literally the day right before I was flying out, and I was like, wait, Steven, like can I meet up with you? And then he's like, yeah, where are you? And then he like picked me up from the airport. And it was like it was awesome. So it's like that's so cool to be able to like go to other places and like know that you have friends in other areas of the world, which is like such a blessing. So many cool people in our tech community.
Perks of being in community. Yes.
And I
Yes.
would like to remind this, because you know how Zach and I started this? It's community. I never met like in 2021 or 22, correct me if I'm wrong. No, 21, I think, or 20.
Yeah. Yeah. 2020
had a-
or 21. Yeah.
Yeah, we had like a virtual AWS community summit thing happen. Like I was in Singapore that time, so Zach and I was like met through that chat, and we were like making jokes, and from start to end, we were there, and then we decided we started like connecting through LinkedIn, and sharing contacts, and then we started like we're thinking, hey, this is really cool. We should do something like virtual, like that's how we started. Trust me, it took us like more than 1 year to meet in person in Thailand. It's another AWS event. So I like we became good friends now, like because of the community, right? Like see what community can do. So that's amazing actually.
I love that. And it's
Yeah.
like even like building up community, like hiking in the desert, Zach. Like, oh, like where do you get to do stuff like that? Like, you know what I mean? Like, it's just that's crazy. Like the literally, it was like my flight landed, and I had legitimately 45 minutes to like check into the hotel, drop my stuff off, and then like scoot to the desert or find the bus. I was like literally running around the hotel, and I felt like I literally ran like 2 miles just to like get to the bus to get there. But it's like the things you do for a community, right? You know.
Yep. And every re-event, the tradition of pre-event hike is really amazing. Was
No,
it the
that was
first time
cool.
that we met?
Um,
I think so, right?
I think so. Yeah. Yeah, but specifically the pre-invent hike. I'm
Sure.
pretty sure that was like the first time, right?
Yep.
That's awesome.
I missed 2 times. Hopefully this year I'll be there.
We gotta make it. You gotta do it. It's so much fun. Yeah, I was exhausted like literally the entire week after that, but like worth it, 1000%.
You guys should come here and do a hike in New Zealand. It's beautiful.
How high do you know like the elevation? Like what's like a typical hike for you? Because I'm like, I feel like
I'm
after
not
like
pretty sure
3-4
about
miles,
that,
I'm
but,
like, whew.
yeah, but it's a breathtaking view, and it's so amazing. And the best
Yeah.
part, we don't have any snakes or spiders. Nothing. There's nothing to worry about. No predators at all. So
Ooh, love that.
Yeah.
Yeah, not trying to get bit by snakes.
Yeah.
No, thank you.
Yeah.
Yeah, another reason why I'm inactive on Instagram is because I see all the NZ stuff on my feed. Thanks to that.
Oh my
Cool.
God.
Nice.
Awesome. So yeah, what are we
okay.
talking today, Brian?
All right. So I feel like this is an important topic because I personally believe that there is no better time to become a software engineer. This is like not to like get on like my horse, but on my high horse, but I feel like there's never been a better time to be a software engineer. Like especially right now with like the ability to talk to LLMs, the ability to like learn on the web, like so many more people are making content, so many people are educating in the space. So with that, there's like way more people that are building, which is awesome. And I feel like one of the things that I get asked a lot is how do I start building this techie stuff? So you see like ChatGPT, you see Perplexity, you see Claude, but then you might see like Bolt.new, you might see Replit, you might see Code Sandbox, like you see all these different apps and they become like, I can't like live without this. Like you think about Instagram, LinkedIn, X, trying to think with Facebook, like email, like all these different apps that you use, right? And you're like, how do those actually get built? So this talk's going to be talking specifically about if you want to go and build stuff, like what's your toolkit? What are the things that you need to do? And it's heavily going to focus on infrastructure as code, which like for anyone that's like not familiar with that, it's going to be like, what's that? But it's basically using code to deploy code. And it sounds like so much more simple than it is. But at the end of the day, like it will help you build and architect systems faster and like more completely and in a predictable way. And that was like a big eye opener for me. Like when I first started realizing like the value of automation, because like you see on like Instagram, there's like all these things of like automate this, automate that. But then it's like, okay, like those are maybe like low code, no code tools. Like what does actually automating code look like? So that's what we're going to be talking about today is if I wanted to go and build an application or a software, literally where do I start? So hopefully by the end of it, people will either be inspired or they're going to be like motivated to be like, okay, I want to go and do this thing. I want to go and build that app that's like in my head, but is not on the web yet. So
yeah, with vibe coding, it's a lot easier, but let's see how easier it is.
Exactly.
You want to get up your screen?
Yeah, let me do it. Let's vibe it up. Right. Cool. All right. Let me know if you can see my screen.
Well, it's still not vibing. Oh yeah. Yep.
Nice. Okay, cool. All right. Okay, cool. And now we're like on the side. Okay, sick. So what we're going to talk about today is how to unlock tech of tomorrow, right? How do we automate the future of code? So my name is Brian, as I'm sure you all know. So I want to be really clear in saying that the future isn't just coming soon. I feel like there's this whole thing of a lot of people are like waiting for the right time, the right possible moment for like the right tool to be deployed, the right AI model to be available. And you're like, oh, I'm going to wait for like 4.0 image generation to be available. Or like, oh, like Claude, 3.5 is like, not really, I'm going to wait for 3.7. But like, I want to tell you, like, I've spoken to a lot of engineers and the people that are building the apps that you're going to deploy are shipping right now. They are not waiting. They are actively deploying or are building huge infrastructure in the cloud. So I want to give that as like a motivator for anyone that's like, oh, I want to like learn, like take the right course, or I want to take the right, workshop or whatever. It's like a lot of people are like literally vibe coding or like vibe learning, and then they're just building the thing. So I want to like motivate everyone to sort of be like, you should start right now. So my name is Brian. And when I talk about starting now, like I literally got into tech kind of by accident. So I was working in a completely different field. If anyone's familiar with public relations, that's a lot of like working with journalists and reporters and getting like earned media. I did a lot of social media stuff. So I was managing a lot of social media accounts, working on tech companies. And I just happened to go to a hackathon one day, literally like spur of the moment, for a weekend. And it like absolutely changed my life. I saw these like cracked 10x engineers that were just like shipping tech from their laptops in like the span of hours. It was like, I had never seen that before. It was just amazing. And that was literally back in 2019. And that's what motivated me to want to become a software engineer. So I left PR, dove into tech, did a lot of startup stuff, built Tech Stack Playbook, and won some hackathons. And I just became literally this like lifelong student. It was like reminding me of like back in the day in college, you like take all these classes. And then when you graduate, it's like, oh, I want to keep learning. So I just encourage anyone that's like, if you ever want to become a software engineer, you totally can and you totally should. It will just unlock so many opportunities for you, as it literally did for me. So where do we start off with this? So if you wanted to go and build something, we sort of want to think about like, is this user facing or is this like a front end system or an application would assume it? So I've built a lot of stuff with Next.js, which is a React based framework run by the company Vercel, or they maintained by the company Vercel. And you'll see in the Google Trends that like it has only increased in relevance and interest over time. This is like a 4-year historical. So it's just continued to get more and more popular. Fast API is completely what I use for a lot of backend frameworks. I do a lot of stuff with Python. So Next.js is your TypeScript Fast API could be your Python backend. And not to like shill these, it's just kind of like, let's just get some examples of some ideas of what we can build with. And Fast API, I think I saw that they're doing like now a managed hosting service for Fast API. Like they're kind of advancing on it, a lot of it. So 2 really great ways to start building. Now, how do we deploy the thing that we built? So let's say that we built our Next.js app, or we built our Fast API thing. How do we deploy this? How do we like manage the system? So you'll see here that this is CDK, this is Terraform, Pulumi, AWS Amplify, and CloudFormation. These are all ways to deploy to, these are sort of like if you wanted to deploy to like any cloud, you could use Terraform or Pulumi, but I've mainly deployed just to AWS. So I look at Terraform, CDK, Amplify, Pulumi like a little bit. It's pretty cool. And then I've had to do some like pretty like hardcore CloudFormation stuff with Terraform. So those kind of can be good as a pair. But you sort of want to think about like, this is how you're going to package your code. So how do you basically take the resources that you need? You need like authentication, you need database, you need storage, you need serverless functions, you need like a Kubernetes cluster to run something. You're going to like want to run that as code. And we're going to get into like why you want to do this, but just think about these as general topics. These are going to be the things that you want to think about, that you might want to pick one of these and use. Then how do we scale? So Kubernetes and serverless, these just always hit. These are getting like tons of impressions, tons of searches. People want to know like, do I maintain the workload with like a like managed Kubernetes or container or something? Do I use serverless, and do I use like serverless like Lambda stuff? So those are sort of like 2 different flavors. It can be very divisive in the tech community from what I've found over the years of like which one's the better one. And I'm gonna like put on my consulting hat and be like, which like depending on what you're building, it completely depends. But I would say like the wrong solution is to like not pick one. So you're gonna like pick whichever one is like going to accomplish the job in the easiest way that you understand. And then you might find out like down the road that you're like, oh, okay, we gotta like migrate to like this other system because it's too expensive right now. Or maybe it can't handle the demand that you need and you need to like completely re-architect stuff. So that happens all the time. You might not get the right answer on the first go. But again, like the worst thing you can do is not deploy. So just to kind of give some perspective. So let's put this into context. What if you were trying to build ChatGPT and this was your side project? So, you know, you're like trying to build this like AI application and, you know, you're like, you might be working maybe in tech, maybe not. And you just want to like build an app. Like how could we think about this? So what we're actually going to build. So let's say that we're building like the next generation AI question and answer app. We're going to pretend like ChatGPT doesn't exist. So ChatGPT fits in your pocket, built with open models, shipped at the speed of Vercel, smart enough to scale itself. It's like the mega app, right? And it's going to do all the things. So there's going to be a lot of considerations. You're going to think about model deployments. Like how are we making these AI models ourselves? Are we maintaining them? Are we going to pull from another company that built the AI model? CI/CD pipelines, which you'll see in a little bit. How do we automate the build of this? How do we test this? How do we implement a feature? And then how do we deploy it? And then full stack, Next.js, Tailwind, TypeScript is going to be how we build like our actual application users will use. And then like kind of like DevOpsy type stuff. So how do we build serverless or maintained server full architecture so that it scales based upon demand when it counts? I'm going to pause because I know I've been like talking like super fast. There's like a lot to get through. How are we feeling? Also, I feel like I'm seeing like a lot of questions in the chat. Do we want to like answer some of these or like
not questions, but more of opinions about what people are using for their tech stack? And like you said, now is the time to deploy, right? So yeah, Bhavesh, he's one of the community members from India. And,
nice. Welcome.
Yeah, welcome to the show, Bhavesh. And he says, yes, Express.js for APIs. He's recently learning Go. Yeah, you always have to be learning something. So yes.
Yeah, I feel like that's one of the things too, where it's like you might not know the skills going into a build, but that's like the fun part. It's kind of like you get to figure it out as you go, choose your own adventure. So totally agree. I need to really look at Go more. I feel like I've talked to a lot of people recently that are like using Go for like APIs and like Lambdas and stuff. And I'm like, that's like the one programming language I like don't use enough or like think about as much.
Yeah.
But it's
In
really
terms
fast.
of,
It's very performant from
yeah,
what I've
yeah,
heard.
yeah. In terms of performance, I believe it's Rust and Go that
Mm,
in the space. So
I
yeah,
was gonna say Rust.
yeah, Rust,
Rust.
sure.
And yeah, Go, you can do a lot of things, right? Like I'm wearing the Kubernetes hat and talking now. You can write a lot of controllers because Kubernetes is basically Go, right? So yeah, Go is amazing. You can do so many cool stuff.
Ooh, okay. I'll add that to my to learn for this year. Nice. Okay, cool. All right. So the vibe stack. How do we iterate quickly? And I do think that like the ability to code fast, like we've never been able to like build quicker now. Because now you can like go in and be like, I want a web page that has these features with these icons and these buttons and like go. And then you might be able to like check a different vibe coding platform and be like, what does Bolt do? What does Replit do? What does V0 do? So think like you're trying to vibe code with whatever will help you move the fastest. And sometimes that could be like spinning up like an application to interface with a backend system. I think some of the vibe coding platforms now can let you like actually build like a kind of like scaffold the backend. So if you want to do like fast API or Flask, you could like have it go and start provisioning it. I don't know how that works with like actually like running it and like testing it, but yeah, it seems like pretty cool to like see how these systems are evolving, because it's like you can build a front end app, but like can it work? That's kind of like the main thing where I feel like it's the vibe coding like elements that are like helpful, but then sometimes like you actually will need to like build the infrastructure. So a lot of this pipeline ends up becoming you push code, you get instant feedback. Your MVP is live, and you can integrate third-party plugins, and then you can add kind of like the back end magic. So that could be like authentication, it could be database, it could be storage, but those are kind of like behind the scenes, and like you don't necessarily know like how it's working. It just kind of like that it is working, and then you're really like flying close to the sun in the best way possible, but like there's going to be a lot of stuff that you won't know. Like it might just like deploy this to an endpoint and then you're like, okay, this is on the web, but like how did it get there? Like can this scale if we reach like 1,000 users that try to do the same thing at the same time? There's like a lot of there's like a lot of questions that are like left, and I feel like that's where vibe coding kind of like is cool, but then there's a lot of it leaves a lot of questions as answers, a little bit more of like a personal take. So then let's say you get traction, so like you post like a TikTok or an Instagram reel or YouTube. I'm seeing like the comments now. Oh, hey Steven. Oh, that's so cool. All right, tell them I say hi. Okay, cool. So let's say that you get traction, right? Your like TikTok goes viral, your YouTube video goes viral, and then people are like, oh, I want to sign up for the Zacs Show's like application. Like it's amazing. It's like this LLM that can talk to tech. It's so cool. But then you're facing really like grown-up problems where maybe you built it with this vibe coding platform. Not that you guys would do that, but this is just for example purposes. But it's like could be like cold starts, right? AI models might be too slow, or they could be rate limited. Maybe you only get a certain number of calls, and then now like your users are using it in a way where like now you need to start paying infinitely more to be able to give them access to something. Maybe users all over the world can't use your app like they used to. It's kind of like back in the day, the app was like amazing, and then like now it's not, because now like too many people are on it and it's slow. And also like data bills and like cloud costs related to running functions, they might make your wallet hurt a little bit if you aren't prepared for some of the bills and some of the costs that could come through that. So welcome to the world of how do we scale this without rage quitting? And I feel like this is something where I've spoken to a lot of people that will like vibe code an app, and then like something will happen, and then they're like, oh, I'm going to give up because like I can't revert back to a previous state. I lost the code. I can't go back to like the previous checkpoint. Something happened, like the service isn't working. And this is why this literally begs the case of like spending a little extra time to learn how to architect correctly and learn how to build infrastructure as code can actually save you a huge amount of hurt and pain down the road. And then it's like you have like more ownership of the project. It's less like black box and more you're actually in control, in the driver's seat. So building it the right way, or like kind of like getting the right, there's a lot of parts here if you're trying to build like a ChatGPT type clone, but the whole goal is to productionize the workload. So let's say that you have kind of a working MVP, but now you want to like make this scale. So cloud native is literally just another fancy way of saying just put it on the web, put it in the cloud, and have the service scale it for you. So now you have scaling requirements because, yeah, sure, you can have people log in and log out, but what if you have like 500,000 people sign in, or like 500,000 people like log into your application, or they want to do something? 1,000,000 people. What if you have like millions of people doing the same thing at the same time? That's going to break a system that doesn't have scaling by default. So when you push code, you want to automate the reviews, the deployments, and then you, of course, want to have happy users at the end. But there's a lot of things that can come at play here. So if you have like a front-end app, we're going to do Next.js, TypeScript, Tailwind. That's going to be kind of like our front-end framework, right? This is our app. But then if you want to distribute that, put that on the web, you could use Vercel. I've used that a bunch. It's great. But then you might want to have more control over, like, if you can only access it via a VPN. You might want to put this on CloudFront, and the code is stored in S3. Maybe you have Lambda for some server-side rendering, server-side functions. But then maybe you want to like lock it down to like a specific set of IP addresses, like your company. Like you want to make an internal tool. You don't want it to be public. Well, then you're going to need to like have a whole system to like maintain that. And you don't want to be doing ClickOps going into the console and like deploying that. I put Amplify and EKS. EKS is Elastic Kubernetes Service. It's kind of like a managed Kubernetes system for AWS. Also, ECS, which is their container service. And those are kind of like backend / distribution. Like if you wanted to build a backend and then deploy it, those are kind of like ways that you can like do all the things and then have it just like be on a URL. But then backend, how do we think about data? Database like NoSQL versus having Postgres or something like that. Like how do we think about that? Having search. So like we all love search. Search is very expensive. So how do you manage search for your database, for your items? Imagine like, I think ChatGPT just now implemented search, but like imagine like you have like millions of rows, or like Discord had a really cool way of like implementing search into their data model. They actually use NoSQL, but they have like a very efficient way to like manage search. So kind of like cool stuff. Authentication, Cognito. You could also use Auth0 or Okta. AppSync and API Gateway. These are ways where you can like allow users to have CRUD functionality, but then you authenticate it. So like I only can look at my chats, but I can't look at Zach. Either you like your chats, right? Or I can't like get access to your profile information unless you share a chat and you make it public. Then the AI stuff. So Bedrock, really great way to be able to just work with like state-of-the-art foundational models that are all ready to do that. You can also tune and fine-tune your own model if you want. But let's say that you want to like build your own custom AI that does like very specific things. You could take a state-of-the-art model, you could then train it, you could do like fine-tuning, and then you could like deploy that to SageMaker on an endpoint. And then now you have like your own managed provisioned instance of an AI model. Where that actually comes into play is you see AI models go down all the time. All the people like you check on Twitter or X, and then you're like, oh, is ChatGPT down for you too? If you need to have 100% uptime, you can like manage your own AI, and then now you can actually call that within an app. Will it be as performant as like these other models? Well, that's a question more of like, that's like a skill issue. Like that's if you have a team of people that can maintain a model, you'll want to be maintaining that as a system. You'll probably want like a data engineering team or something like that. And then ECR. So let's say you want to like deploy, like do Docker build, Docker deploy, and then you want to like host that in AWS. You could use ECR, and then you could like version your AI models. There's a lot of things that you could do, but these are like some of like, I think the highlights. And then of course, caching, like you could use Elasticache, you could use Memento, you could use Redis, and then of course, like cache relevant queries or like relevant information for your data backend for users. It gets even more complicated. I'm not going to go through all of these. Like we kind of like walked through all of this, but it's like the list can stack very high of the requirements that are made, and especially trying to maintain security for your system. Like how do we do that, right? There's going to be like so many different elements. So then you're probably thinking like, yikes, do we really need all of that? And the short answer is yes, you do need this, because if you don't know how something is built, you don't know how to scale it. And the reason why that's really important is because you want to remove ClickOps. And ClickOps is like a kind of like a funny word for like, you go into like a web console and you like click a bunch of buttons and like deploy stuff. You don't want to do that, because you want to make sure that you have like a pattern. So think like if you go to, not to bring like fast food into this, but it's like if you go to like McDonald's, imagine like you're not using a recipe to build the hamburger every time. You're like randomly getting the lettuce from someplace and randomly getting like the patty, but the patties aren't made yet, or some of them are, some of them aren't. And then like maybe one of them has two, but you only have one patty, so you need like another one. And then you need like buns, but they're not, toasted, and they don't have like the sesame seeds on it. So it's like, if you don't have a recipe to build something, you don't really know how it works. I will say that learning infrastructure as code has actually helped me learn cloud so much more, because it actually will like tell you if you know what you're talking about or not. And it kind of like a little bit gaslights you in the sense of like, do you really understand what you're building? And that's kind of where like, if you're trying to build like, okay, so for example, like I was building like a knowledge base with Bedrock, and it's like you store the information in S3, and then that knowledge base can like read from the S3 bucket, pull down the relevant data. We have like a vector search that's through OpenSearch, and that's like a managed search for those documents, and you have vectors so it can find everything. And it works great, but like if you wanted to replicate that process, there's a lot of buttons that you'd have to click, and a lot of stuff that like you might not do correctly if you try to replicate the clicks. So if you can build a recipe, then, oh, that's so funny. Someone in the chat said burger is code. Yes, that is 100%. Yeah, that's exactly what you want. You want to have like the McDonald's recipe, like this is what it is, and you go and do it and like literally print burgers. So that's why you need to treat your infrastructure like a modern like USS Enterprise from Star Trek. Like you don't want to treat your infra like 2009. We have tools to automate this. So Terraform, CDK, Pulumi, serverless framework, there's SAM, there's Amplify, there's like all these different tools, which is amazing. And you can version, you can roll back instantly, you can scale stuff, but this is why it's really important. So like ChatGPT, we have our app and we have our backend, but we don't want to think of them as like one vibe coded thing. We want to think of them as separate. So like the backend system could be a server, and that might be maintained through AWS CDK. But you might have Next.js, and that could be deployed to CloudFront or something like that. And you want to just like have Terraform be able to like manage that. So you're sort of doing a separation of concerns. And the app, you go and do the app stuff. The back end, you deploy to Kubernetes with like fast API, and like that's with CDK. And then you have like IAM roles that can like assume, or even like VPC, you can like allow certain resources to call certain other resources, but you don't want to like have everything all in one bucket. And that's what a lot of like vibe coding systems do, is like all the things are just one blob. That is like not how software like will build. You're going to run into scaling issues. So why is continuous integration and continuous deployment cool? Okay. So what's really cool about this is that when you like go and like push deploy on like a vibe coded platform. I also want to be like vibe coding is cool. I'm just saying like I'm using it like as an example, like a counter. So like when you click deploy, it's gonna like go and do the third party stuff. It's gonna like get it on the web, and then you're like, wow, that's cool. But there's gonna be a lot of stuff that you might actually really want to check how it's being built, because if it's kind of like in a black box and you don't really know like what's happening, you could have a lot of questions. So security, for example. So Amazon Code Guru or Sneak, those are really great ways to do code scanning. Why would you care about code scanning? Because they're like, if you go in Google, this is kind of like in like hacky, like pen testy communities, but there are instances where like if you're using open source packages and like someone got access to a package, and this like doesn't regularly happen, but it can happen, and it's like very scary if it does. Not to be like fear mongering, but it's that like if you like use an open source package and you don't actually maintain the code, and someone like got access to it and pushed like malware into it, well now like if you go and build with that system, now your app has this vulnerability in it. And if you see like when you do like npm build, you can see like npm will like give you like vulnerability analyses of your app, but then like how do you catch those before you build it? You want to use something like this to actually like scan your code and make sure that everything's fine. And you want to also make sure that like the packages you use are secure, and also like the way in which you build with them is secure. So there's like a lot of cool ways you can do this now with like, of course, Sneak and Code Guru, but also Amazon Q Developer and GitHub Copilot. Like you can add those into your CI/CD pipeline, so it will like do reviews as you push code. And now it's kind of like you have this smart AI brain that's like, Brian, like you didn't do this right thing, and like you got to check this out. You know, you got to like make sure that like the code is like coding correctly. Even observability, right? Like think about oh that actually should not be Sneak. That should be Sentry, another S word. But that is not Sneak. That's Sentry, and then CloudWatch. So think like if you want to manage how your users are using your application, or basically like review certain things and like alert your team that like something got built and something got deployed or something's wrong, you can like deploy these services, and then now they're a part of your stack, and like you can analyze like what's happening in and around how your users use your app. Other thing that's like 10 out of 10, can't live without it, automated deployments. I say this because my first tech job, actually one of the things that I did was I like learned CI/CD kind of like by accident, and then I implemented a CI/CD pipeline because what our team like was doing was building like the app and then pushing it to it was like GoDaddy managed hosting, and it's like kind of janky, but like it works. But it was like I literally had to like build this app and then like drag and drop it into like this like GoDaddy bucket. And GoDaddy's great. It's just kind of like that was like maybe like 20 minutes, 25 minutes of like time, as opposed to just being like click deploy to Git, and then like now GitHub's going to be running its thing. You can also deploy it to a dev stage and prod, also add feature branches. These are ways where you will just like code way faster. So that is just like ways where you can just like instantly level up the code base and just make sure that you are repeatedly building your code, especially for the resources, right? You don't want to, again, like burger is code. Like you want to be printing burgers. You don't want to like be like pulling out stuff like, you know, kind of like randomly. Okay, I'm gonna like pause. How are we doing?
Maybe remove tomato from the burger.
Yeah. Like, and what if you don't have tomatoes? Then you gotta like go and grow some more. But
cool. We have some questions in the chat.
Let's go for it.
Yeah.
Okay, what are your favorite use cases to automate? Okay. Thanks so much, Sonali, for your question. Okay, definitely on the deployment side, specifically in the deployments, feature branches. So being able to like build, basically, so you're trying to like implement something and you want to like figure out if this works or not. So you could go and like on your URL, like just add like a feature branch or something like that to like staging. And then you can like implement and see like, hey, does this work the way that I expect or not? I feel like that's one of the best ways to automate. Because then you like, you know, 100% like, okay, if I like push this to prod, like, you know, all things considered, this should work. So I just feel like that saves you so much time from needing to like, kind of like what I explained before of like drag and drop this onto the thing. You just know, like click, git, deploy, blah. It's like now going through a pipeline and reviewing. I also think like security reviews for sure and code reviews. I was like, to be honest, I was like kind of against like the AI reviewing of my code of like, why would I want an AI like reviewer? Like I know what I'm doing. And then you find out that like none of us know what we're doing. So it's like you want to make sure that like you have the smartest tools at your disposal to help you with building stuff. And then a little bit on like the like kind of like the techie nerdy side from automating. Automating data pipelines. I feel like those are really helpful for like clients or like any sort of like team or company where you basically want to take like, how do I take this like long convoluted process and like basically make like something. So there's something called step functions where you can like go and just be like this part to this part to this part to this part. And that could really be like, I want to take, you know, like I want to take an AI model and like run it through a series of steps and then like get an output. So that's like a cool way if you want to do like multi-model AI, you could have it like review certain things in a pipeline and then like get an output. So those are sort of like three of the top ways to automate. But Zacs, what about you? What do you guys like to automate?
Yeah, definitely the security checks. But yeah, now with the agentic approach with things like QDeveloper and everything with code reviews, well, definitely, because why not have another reviewer take a look at my code, figure out what's wrong, than pushing it to prod and breaking prod, right?
Yeah, exactly.
In my organization, everything is automated. Basically, I'm from a platform team, so I'm from specifically on the EK state. So our platform team is huge. So we have our internal developer portal. So everything is automated basically. So we don't do any manual stuff. Everything is automated. For example, if you're a developer creating a new project, everything through the portal, behind the scene, all the magic will happen. Platform team is taking care of it. So I would say like automate.
Awesome.
Automation is the best, yes. And like you mentioned, right? It's you can predict. So anything you can predict, right? Using automation. So
Yeah. Yeah, cool. It just takes like the guesswork out of it. I feel like when you automate stuff across your team, you can move so much faster because you don't need to be like, oh, like did you like follow these like 50,000 steps to like do blah blah. Like that's kind of where like once you start building like more complicated systems, you'll be like you're spending so much time like reviewing the steps as opposed to just being like, oh, it's like all in code. And like if it can deploy in code, then like you know it can work. So yeah, no, like automation is great. So cool. Yeah, so no, I hope that helped answer your question. Do you have any other questions?
Yeah, we have another one.
Oh, why? Oh, okay. Mohammed says, why
fast API versus others?
Oh, okay, interesting. So I think it depends. I think it's just more of like a familiarity standpoint. So like if you wanted to just like spin up like an API, you could use like AppSync, you could use API Gateway, but I feel like if you want to like build your own server that can like process like proprietary models or like specific workloads that run like in a very specific way and you know how it works, Fast API is just kind of like the next logical step to just be like, okay, like let's just get this on the web and like we'll maintain the infrastructure. And it just gives you a lot more control. So it's kind of like, hey, you build the Fast API thing, you can run it locally, but then you want to like get it on the web, you could just use like EKS or like ECS Fargate or something and like just get it on the web, like in the cloud and then on the web. But yeah, but I feel like if you like building APIs with any other framework, like you don't have to use Fast API. I don't think it's a requirement. I like to think of it of you build like front end apps, but then you could build like back end services and like you could use like Node. I just feel like for a lot of like the AI stuff, you're probably going to be using Python. So Python is just like the logical step to build a server. Because a lot of like there's like TensorJS, or TensorFlow.js, like you could use like JavaScript in certain things, but I do feel like for the vast majority of AI workloads, you're going to be in Python land. So like, but Python is not like intimidating like for people that like haven't built with Python. Like I had to learn Python to be able to do a lot of the data engineering and AI stuff that I'm doing now. So, you know, it can take a bit of time, but like it's super relevant. Like it's kind of like learning Rust. Like if you're trying to do like high performance compute or like programming, like learning C or like learning Rust can be like really helpful, or Go, like what we were just talking about earlier, if you want to like improve performance. You know, it's kind of like you learn it if you need it.
Yeah, I have a question. So you're saying you're learning Rust, and Mohammed, I hope Brian has already answered your question. So if you're learning something new, a code or like a language, right? What is the best advice you can give? Like, you know, how to do that?
Oh, you're asking me?
Yeah.
Oh, okay, so like the question is like how do you go about learning something new? Or
yes, like, let's say okay, suddenly there's a new language comes up, like say Zac. The language is Zac, so you want to learn Zac. So what would you
do? Ooh, okay, I'm gonna answer the question with like a bit of a long-winded question, but I think that I've actually been like a little bit resistant to like learning new tech, and I say this only as someone who like, unless it reaches a certain threshold, because I feel like there's a lot of tech that gets released like every week, and it becomes like a little bit of like a catch-22 of like, if I don't learn this, I'm going to be behind the curve. But then it's like I spent all this time to learn the stuff that I'm doing now, so like how do I like keep up with it? And I think that like if there's something that's just like a clear win, like you just have to do like Tailwind CSS, for example, like that was like a great example of something where like I learned, this is like for front end people, like I learned style components as a way to build front end experiences. And I learned like all of the hardcore CSS stuff, which actually is very relevant now still, but I really didn't use like Tailwind at all. I was like actually kind of against it, because I was like, why are we doing all this inline stuff and it like doesn't really make sense, and this is like this feels like an anti-pattern. But then at a certain point you start realizing that like, okay, like everybody is coding in this, I have to learn it. So I think you want to like it's just like, how much do I need to learn to be like knowledgeable versus being an expert. And I feel like at a certain point, like you might need to know something enough to be dangerous, but you don't need to know something enough to be an expert. And that's kind of where like learn enough to be surface level and like be knowledgeable. But like, for example, Rust, like Rust is cool, but like I have not had a single instance where like I need to know it. And that's just because like I'm not necessarily working on like high performance workloads that are like, but even still, like I might not need Rust because I might still code with Python and like be able to like abstract with like other systems or like up like an EC2 instance and just like, I don't know, build something with Java. Like it kind of depends, but yeah, it's just like, but like Rust is cool. Like I'm generally aware of it. And I went to like a workshop about Rust like a couple years ago, and like it's cool. It's cool to know, but I try to be very cautious of like, am I building excellence in this field, or am I building like jack of all trades, master of none type skill sets? Because then it's like you could know like how to write hello world in like 50 languages, like programming languages, but like does that help you at the end of the day? Like probably not. So it's like you want to sort of think about like how much do I learn enough to be dangerous? So like books, YouTube videos, like building kind of like a to-do app can be helpful. But then it's kind of like, how much more do I need to know to actually like is excellence in this new language required? But it's a question I always ask myself, because I'm a little bit slow to adopt new stuff until there's that threshold, and I'm like, okay, I gotta book it. I gotta like get on this train.
It's more of a
But what do you think
for you to learn then? I mean,
yeah, I'm 100% with you, Brian. So I do the same. Like for me personally, I think it's I mean, as an engineer, we should understand the basics first. Like, let's say if I don't know about the networking fundamentals, I'm going to configure TGW. I mean, yeah, it doesn't make sense, right? Like, you should know what's the basic of networks to do that. So before you go to EKS, you should know Kubernetes first. So yeah. So knowing basics, I mean, I can map those things, like, for example, ECS and EKS, right? Like a task or a pod, a service. So if you know the basics and like deep dive, it's easy to map all these scenarios. If there's a new tool comes like a container platform, Zack, so I can map with this thing with that, and I can learn faster. Yeah.
100%.
Cool. That's all the questions. Thank you.
Okay, cool. No, this was like a good, I like being able to jump in and like answer questions. Feels less like a lecture and more like conversation, you know, so that's always fun. Okay, so like we walked through like all this stuff, but then you're probably thinking like, I'm still not convinced. Isn't like vibe coding and like vibes like still the way to go? Like this seems really too like complicated. And like, you're not wrong. Like it is complicated, but again, like infrastructure as code, like it can make it significantly easier to scale. And like let's like go through like some real examples of this. We're just gonna go through like 4 examples real quick, but just to kind of show like why would you actually want to learn infrastructure as code. So let's say you built, you know, Me GPT, and this is like your LLM powered productivity app, and it's using like Supabase, Next.js, Netlify. It's like your classic vibe coding stack. This works great until, you know, your video goes viral. 300 people, or even like 3,000, like let's say like 30,000 people like sign up for your app, and they all go to like generate my like productivity plan. It's like a prompt that you have to like help you with something like this. Now the app is super slow. There's a high latency. It's like spinning, like loading for like long periods of time. It's like generating for like long periods of time, and then users, they're gonna dip. They're gonna get out of there. They're not gonna have a fun time in this app. They're gonna go to like back to like another AI application. So let's say that like if you deploy like edge functions, like Netlify functions, for example, or like Vercel functions or whatever, like those might be cold starting. So those might not be like provision instances of something. So they're good for like low traffic where you're like on demand and like they're ready when they're ready. But if you need like bursts of like running something, it's not built for that. So that's where we could implement Lambda or Kubernetes. And if you look to your right, you're going to see like 2 different examples of what this could look like. So this is kind of easy to see, like module EKS and then like resource Lambda. So there's just different things that you might want to think about of like pre-warming your containers and having auto-scaling pods on the EKS side. On the Lambda side, you might want to think about provision concurrency. So you could have like provision concurrent executions, and then that could be a way to like make sure that your Lambda is like always ready to go. And you could always like scale that up, you could scale that down, but Kubernetes is really great because like that can like span up and span down based upon like your demand of like a max threshold. So like what's really cool is being able to like think about this of like it could be a serverless workload, it could be a server full workload, but thinking about like how do you handle bottlenecks is something that like you want to really be careful of like knowing how you provision that. If you just kind of leave it up to, oh, the platform decided it, that's where you're going to run into like a lot of these issues where then your app is like, it's not going to be great. It's going to like be in the toilet. You want to make sure that you're able to scale as demand increases. So that's just sort of like two examples where you could use Terraform to architect this. And then now it's like, okay, my EKS is doing this and my Lambda function is doing this. And then you always know that that's what it is. You can always refer back to it as a point of reference. So scalability challenges. So let's say that, you built this prompt generator for shareable features and mutatable prompts in your LLM app. Okay, 10,000 users start trying to create these prompts with the generator, and then your app crashes. And then the prompt generator is frozen and users dip. Why did this happen? So when you deploy, again, with like a serverless backend, that's like third-party stuff, it works until you hit massive scale like this. And let's say that that's like 10K users like hit it and like you're growing exponentially. And then now it's like 10K people, now it's 20K people, now it's 30K people, and it keeps going up. Now you're gonna hit the ceiling of like, this was nice in dev mode, and then now this is like not built for prime time, right? It's not built for infinity or infinite scaling. So enter Lambda. Those can scale horizontally. You just need to watch out for throttling on the API gateway side and concurrency limits. Because sometimes like if you try to run something at the same time, you could run into issues like that. And then Kubernetes. So spinning up pods for traffic spikes when users are like using it at like high frequency times, and real-time scaling built to grow. So you could think about this on the EKS side, where if you have nodes, you could have like a desired capacity, you could have a max capacity where like it can scale up to this, but no more than this. And then you can also like change the instance type if you want to like make it like beefier or not. And then on the Lambda side, you can also have like different like qualifiers. You could have like concurrent execution, kind of like what we saw before. You can also have timeouts. You can have memory size. You can have like ways where you can like make it bigger or smaller, so beefier or not. But those are ways that you can like make the Lambda like be more super powered. Also complex deployment requirements. So now let's say that like your app is hitting. People are like, oh, I love the Zac LLM app. Like this is awesome. I love what we're working with. But then now like you have investors, or maybe you have stakeholders, or maybe like a big company comes to you and they say, I would use this, but it needs to be HIPAA compliant. How can you guarantee that the data is with encryption? Specifically, like let's say healthcare, right? Let's say you have a lot of like healthcare users. That could be like big revenue for your business or your company, but like they're not going to use it because maybe certain things don't have the security that it should. So you can't just go and like vibe code like, oh, like make my app HIPAA compliant. Like you actually really need to be able to know, like, first of all, is that vibe coding platform HIPAA compliant, of which could be a whole other can of worms. So if you can maintain your own infrastructure, you can make sure that your system is actually secure around those things. So file uploads, background, like asynchronous workloads, private endpoints, custom authentication workflows. Like these are all customized things that require work. You want to make sure that you're doing it correctly. So Lambda, that can work with very specific workloads. You can like patch certain like features into a Lambda function and like make sure that you're, running like it correctly. And then also Kubernetes. So you could have like way more control over that. So Kubernetes is down here, Lambda's up here. You just have way more control. So you could have like, again, private APIs, encrypted volumes. You could just like make sure that all of the like resources that are a part of the stack have a compliance for HIPAA. So you make sure that like all your resources are tagged together, and that if you like spin up a feature, you can make sure that that everything's all like packaged up correctly. Otherwise, like if you had like a VPC config, you can make sure that like the specific resources like only can be called within a specific VPC, and only certain resources can talk to each other. That's like all kind of like a networking exercise, but that will make sure that like you can't call something that's like outside of this VPC or outside of like a VPN or something like that. So complex deployment. And then cost management. I think this is something that we can all relate to. We don't want to be selling like organs out trying to like pay our bills, right? We want to make sure that if you like release a feature, that it is 100% like like your ability to afford it is managed. where this can come into play, I think we all saw this with ChatGPT, where when you deployed, or basically when they deployed that image generator and you could do like that, like anime, like animation kind of like effect, that was like printing money, but like not for the company, like to the servers. So to be able to afford that bill. So think about like if you do image generation, each click could be one API call, but then like if you're building like complex imagery, that might be like many API calls to like coalesce all the information together to then like generate the image. That's where like bills can spike, and then you could start paying like a lot of money for a very specific service, which can like not be ideal. It can add up fast. So with Lambda, you want to make sure that, you know, it's good for bursts, but you want to optimize provision concurrency and smart memory tuning. So you might want to increase in the Lambda up here, just like the memory size. You might want to increase timeout, make sure that it's not small like this. It could be like much bigger. And then also just making sure that it's like always available. Kubernetes, same thing here. You might want to increase the instance type, what it can do. Let's say that you want to do like image generation and you need like very complicated like GPU type thing. Well, you don't want to have that be running all the time. You might want to have that run for like a very specific amount of time if the demand is there. So you queue everything, you put it all in a queue, and then you'd be like process, and then stop. And then you do like the next batch. So if you, that's like, it's like really interesting. Because if you ever see like why is it queued? Like a lot of apps will say that like, oh, this is in queue. But that's like what it's trying to do, where it's trying to like cost optimize you generating something along with other people. And like maybe your request is like way more complicated than somebody else's. So they might prioritize like easier images first compared to yours, which might take longer. So that's just like interesting with queues, where like you don't want to be like running like your resources all the time. But sometimes you might need to have a baseline provisioned concurrency of something like, or provisioned like throughput to have something like running at like always, but a minimum base threshold that can always scale up, but then like scale down when it's not in demand. So cost management is super important. So just to kind of wrap up, or by the way, do you have any like questions like so far with here? I saw like just like 2 more slides after this, but
we have a question around what do you choose for something that has less number of traffic in terms of cheaper options for deployment? I think we were talking about traffic and costs. So yeah, what are your takes, Brian?
Yeah. I can go back a little bit. So if you want to like really like mitigate costs, I feel like to deploy, like what's kind of interesting is like you can deploy like for free with like Netlify and Heroku. Like those are like great ways to just like get like an app and like put it on the web. And like I used that for like every hackathon project. Like Netlify was like my best friend to be able to just be like, okay, like I need to like take this app, containerize it, package it up, put it on the web, and like Netlify deploy. So you can also do CI/CD through Netlify, and like it just works great. So I feel like if you don't expect a lot of users, just like think about stuff like this. Like try to experiment with like taking one of these tools and then just like getting it on the web. I think that's like the biggest thing that I've learned is like a lot of people would just like not build the demo because it's like it's kind of like you're like gearing up for a marathon, and you're like, instead of you think of it as like, I'm trying to think how long is a marathon? Like 24, I think it's 24 miles or something, like, or like 24.2 miles. But it's like, instead of you thinking of it as like one marathon, it's like a series of like 1 mile sprints. So it's kind of like to try to get like your app up, just like get like the first mile done. And the first mile done is just like get it on the web and then kind of build it. And then and then we can like kind of scale it from there. But yeah, I sort of think like Next.js, get into GitHub, do the CI/CD pipeline thing, and get it to Netlify. It's just as you start building this out, you're gonna start needing like different things, and if you don't know like how the AI models work, like maybe the AI stuff is fine for like API keys or whatever, but it's just like as you start scaling your project and you hit like maximum demand, like that's where you're gonna really want to start thinking about like these other things, and that's kind of where like you take ownership of the project and like the app. But super inexpensive to get started. And also with AWS, you can like deploy a lot of stuff with Amplify. Like I think I had that in here, like here with Amplify. This is like a great starter. Like they just added WAF to it, so you can like build production ready apps like with like AWS. Like it's just great. And you can also deploy it to like CloudFront. S3 can get more complicated, but I would say like for AWS, like Next.js Amplify, absolutely insane combo. Okay, hopefully that answered your question. Okay, cool. And yeah, it's just kind of like with software, it can get expensive and time consuming, but infrastructure as code makes sure that you are just on the right track. So that's how we keep up with it, and coffee as well. So these are just like some examples of like, if you want to build an application, like you would really need to make sure infrastructure is coding this so that like it's not just, again, ClickOps, because it can get like complicated. Same thing with here with automated AI code scanning. Like you can just like allow your code to just be like reviewed. This is like an example of that, but it's just like, it's very cool to like see how that can work. And I just leave with saying that like, there's a ton of hype in the space for builders. Do not believe like all the news of like, oh, like it's not a good time to be a software engineer. Like, I think there's a lot of like gatekeeping and there's a lot of like fear mongering stuff that I'm seeing. And I just feel like think about all the companies that are like raising huge amounts of money right now, like building AI apps. AI agents are not building those things. Those are real engineers that are like excited and passionate like you. So that's why like you should go and build the thing, because like everybody else is. So it's kind of like take that app that's in your like the app idea that's in your brain and then just translate that and put that on the web. So these are hireable skills as well. And these are also things where like you can like build like really great tech. So that concludes all of the parts of this topic. So, and this was like a good conversation too. So yeah, thanks for
Brian.
joining everybody.
Amazing stuff. I like how you put it, like talking about serverless Kubernetes and choosing what's really important and what's really needed for that moment, because you may not always want to build a Kubernetes workload when you start off small, right? Like Sonali wanted to build something as a side project, starting off small with Netlify or Amplify or even serverless on the back end is really good. But when you scale, you kind of go back in and things on your back end, choose the right architectural choices at that point, and scale up. So, yeah.
Oh, 100%. And you might not know, like that's kind of where I left it towards the end of like, these are like considerations if you're facing these problems. So it's like you hope that you never face those problems. Like you might be fine, but it's like knowing that like if this was to happen, like are we prepared? And then it's kind of like, do we have like a backup plan or a backup plan to the backup plan to like get us out of this like hot water if like something goes wrong? So it's like those things you want to keep in the back of your mind, but that shouldn't keep you from building, right? And like Kubernetes is like a little bit of a lot to like start with building like a demo app. But if you do need to like provision a server like a ChatGPT or like an AI type like backend server, you're not gonna just be able to like run that with like a Lambda function like that, or like an edge function or something like that. Like those third parties, it just won't work. It will like break if you have like 10,000 people plus like accessing it like a second or whatever. So just things to think about, you know.
Yeah,
I think
that's why you need engineers.
I love that Kubernetes part, like how you map one by one from the zero scaling. Yes, so there are tools like KDA, Kubernetes event-driven autoscalers. You can scale your pods, depends on your SKU, depends on your load balance traffic, and it's so many scalers are there. And like Carpenter, right? Like everyone is talking about the auto mode these days. So basically it can save a lot of money, and from you can scale such thing like 0 to 1. So like you mentioned, Brian, like you can run your workload there, but you want to scale up, scale out based on your request, maybe a SKU or traffic coming through a ALB. So yeah, amazing. So I really like how you map those things, and the analogy. Thanks, Bhavesh, about the Burgas code. That is my key takeaway. That I love that analogy. Now, if anyone asks what is IAC, this is the analogy I'm going to use. The best.
It's so, because it makes sense, right? Like you think about it and you're like, there's no way that they're just like coming up with the recipe on the spot. Like you have a hamburger recipe, you can just literally print hamburgers. That's what we do with code, you know?
I just love it. Yeah.
But it's such a great comment. Yeah, I love it.
Awesome. Yeah, I don't see any other questions. But yeah, I mean, that was really insightful, Brian. So, I mean, I have always been serverless first mindset, right? And that's, I mean, I have seen in my past organizations where we have built serverless first, and then we went back and we are like, hey, no, this really needed a container approach. And we have redone a few things. So yes, starting off, it's always good to start small, and that's the way you'll get things faster, right? And I think you also mentioned like deploy, and deploy it on the cloud. And to do that, it's easier, and something that's really lightweight is a good starting point.
Oh, 100%. There's a lot of like cool stuff you can build with serverless. Like even like just the other day building DynamoDB streams. So like the database gets updated and we want to like do something else. So being able to be like on an insert to the database, like run this job to like process something and like update that field with like this. There's like so many cool use cases of it. So like, do you need Kubernetes to do that? Like probably not, but you might need like provision throughput of like, and like max concurrency to like scale with that. So it's kind of like knowing like how do we expand our needs. So, and you can do that with serverless or, you know, servers.
Yeah, I think one thing that I would probably want to add is serverless is great, but for longer running jobs, you need containers and Kubernetes. So yeah, something with, especially when you're working with AI, right? And it takes a heck of a time for things to generate and give back responses. So unless you're working on a managed thing with, be it with Bedrock or any of the other models that are there available as OpenAPI SDKs or things like that, it's good. But if you're running your own model, you need containers, you need Kubernetes. And yeah, it all comes down to the amount of payload that you're working with, the workloads that are there, the traffic that comes into place. So yeah.
No, great points. 100%.
Awesome.
Cool. Seems like no more questions. But if there are any question, feel free to reach out to Brian.
Yep. Thanks, Brian. Thank you, Zach, for.
Thank you. So we'll see you.
Yeah, thanks for having me. Yeah, you guys are like, our time zones are so crazy. So thank you for coordinating all of this, because it's like, it's hard to map like all of our time zones together. So thank you for having me on and working with your schedules. I know you're both so
Thanks,
busy.
Brian.
Yeah.
Thanks for being a comedy.
Jones is going back to bed, and I just started my day. Brian is in the middle.
I know. I'm like, I'm going to be going to bed at some point.
When I wake up, so yes.
Yeah. Cool. Nice.
Awesome.
Cool. Well, thanks again for having me. This was so much fun. I hope we can do this again.
Hopefully, waiting to have you on the Zacs Show very soon. So yes, fingers crossed. Awesome. So thank you all for tuning in, and see you soon on the Zacs Show Talking AWS. See you all.
Bye, buddy.